Hi folks, this is a video about factoring and solving polynomial equations. This goes with section 6.4 in an Algebra 2 textbook. After this video, you should be able to factor polynomials using previous techniques, which we'll go over in a second. Also, you're going to learn about the sum of cubes and the difference of cubes. You're going to learn about grouping, about quadratic types or quadratic forms, and you'll also be able to use factoring to solve polynomial equations. Okay, so a quick review of previously discussed techniques. We had greatest common factor, we had general trinomial factoring, perfect square trinomial factoring, and the difference of two squares, something like x squared minus 9. So those are previous techniques that you should be pretty comfortable with at this point. Okay, so let's just jump right into the sum of two cubes and the difference of two cubes. Well, as the name implies, guess how many terms we need? That's right. We need two terms. So it's nice because when we have three terms, it's generally a trinomial factoring. So difference of two cubes or sum of two cubes is going to stand out a little bit. So it's just a matter of being able to apply the formula. At the CT level, you do not need to memorize this formula. Honors, this is something that I expect you guys to memorize. So I'm going to write down a generic sum of two cubes, a cubed plus b cubed. And I'm going to factor this. And this basically is, this is the formula that you should know and get used to using at least. Okay, so my first parenthesis is going to have two terms. My second is going to have three. That's the first thing right off the bat to know kind of what's coming. So I'm going to look at my first term, and I'm going to take the cube root of that. Well, the cube root of a cubed is a. That's going to be my first term in my first parentheses. Likewise, I'm going to take the cube root of my second term, and that's going to be my second term in the first parentheses. Notice how these signs are the same, plus and plus. Okay. For the second part here, I'm going to take my first term here, and I'm going to square it. I'm going to take my second term here, and I'm going to square it. And those become my first and my third terms in the second parentheses. In the middle is going to go the opposite sign, so minus, and it's the product of the first times the second term. So a times b. And that's how we factor the sum of two cubes. With the difference of two cubes, I'm just going to do a little sleight of hand here. So if it's a minus b, it's a minus sign. A cubed minus b cubed, this is going to factor to a minus b, so that sign changes. And this sign over here changes to plus. So notice how all the green signs are on the bottom, and that tells you which ones to use for the difference of two cubes. So let's look at a nice little example here, something like x cubed minus 27, and we're going to factor this. So again, a short one, a longer one. And what I'm going to do is I'm going to write to myself what a should be and what b should be. A is going to be my base of my first term. So what cube gives me x cubed? Well, that's going to be x. That's nice. Okay. Now, what cube is going to give me 27? Well, that's going to be 3. So b will be 3 in this case. So now I'm no longer looking at my x cubed minus 27. I'm really just using my a and b values over here to fill in my parentheses. So I'm just going to follow the pattern up here. I'm going to have x is my first term, 3 is my second, and in between them is going to go the same sign as what's there, so that's minus. And in my second parentheses, I'm going to square that a value. I'm going to square that b value. And in the middle is going to go the opposite sign of that, so plus, and then the product of a times b, which is 3x. And that's it. I factored the difference of two cubes. What's nice about this is this quadratic over here, will never be factorable. Unless you get something that's really strange, but that's really beyond the scope of this class, unless you get, it just won't happen. So we'll just say that this one's never factorable. Okay, so let's do a practice problem. So we're going to factor 16 u to the fifth minus 250 u squared. So when we did factoring earlier this year, one of the things I kept mentioning to you folks is always try what first. We'll always try greatest common factor. Is there something that these two terms have in common? Well, something that should stand out is the u's, right? We have a u squared that we can pull out, okay. And then we should also notice that 16 is even, and so is 250. So at least a 2 can come out, and maybe or maybe not something else. And as it turns out, it's just a 2 that can come out. And now I just need to figure out, well, what's supposed to be left inside? Well, u squared times what gives me u to the fifth? Well, that's going to be u cubed. And 2 times what gives me 16? That's going to be 8. My minus is there. Half of 2 is half of 250 is 125. And if I've pulled out a u squared, then there's just a 1 left. So in other words, 125 is my second term there. Okay, so let's take a look at this and see what we have. Well, we have 2 terms left inside. And we're subtracting, obviously. So this is looking like this might be the difference of 2 cubes. And there's some other major clues here that are going to help me out, like that u being cubed. That's a major clue that this is the difference, or maybe the sum of 2 cubes. 8 is a perfect cube, as it turns out. And if you don't know by now, you should probably take a guess. 125 is actually 5 cubed. So that's what I'm going to do here is I'm going to mark down my a and b values. So what should a be? Well, we know that the cube root of 8 is 2. And we also have that u in there as well. So I have to take that into consideration. So my a value should be 2u. B is going to be just the cube root of 125. So that, as we said before, is 5. And now that I know what a and b is, I'm going to go ahead and use that formula from before, which is, here's the right side of it. A minus b times a squared plus ab plus b squared. So I'm really just going to throw my 2u and my 5 into this, and that'll be factored, and I'll be all done here. I do have that 2u squared outside, so I should probably put that first. And then I had a is 2u minus b is 5. Let's see, a squared, that's 2u squared, or 4u squared. Plus a times b is going to be 10u. Plus b squared is going to be 5 squared, or 25. And there's my factoring for that thing that we started with way up top. Okay, moving on to another type of factoring. This is called grouping. So a distinguishing feature about grouping is that it requires 4 terms. So again, really nice. Trinomials, we know they have 3 terms. Difference of 2 squares, or sum of 2 cubes, difference of 2 cubes, 2 terms. Grouping just looks different. So that's the first thing that I look for, is the number of terms. That's going to help me with grouping. Okay, so here's how grouping works. Grouping is a little bit different. So what I'm going to do here is I'm going to, as the name would apply, I'm going to group my 4 terms into groups of 2. Usually it's the first 2 terms and the last 2 terms, but it can be done different ways. I'm going to do the first 2 terms and the last 2 terms. So when I look at these first 2 terms, I'm going to factor out a greatest common factor. Well, the greatest common factor there is an x squared. So I can pull that out of the first 2 terms only. When I do that, well, what are we left with? Well, x squared times what gives me x cubed? Well, that's going to be x. Okay, x squared times what gives me 5x squared? Well, that's going to be 5. So I'm going to be left with an x plus 5 on the inside. And now we're going to move over to, and pardon me, I'm going to change my color here. You'll see why momentarily. This is x plus 5. I'm going to move over to my second group. And I'm going to pull out the greatest common factor. So over here, I definitely have a 3 in common, but here's a clue for us here. And you'll see this as you do more of these, why this needs to be the way that it is. But what's left over here needs to be the exact same thing as what's inside this first parentheses. So what do I need to do, or what do I need to factor out in order to make negative 3x minus 15 into x plus 5. Well, I need to pull out a minus 3, as it turns out. So when I pull out that minus 3, I factor that out from my second two terms, and now I'm going to do the last step in grouping, and here we go. So here's what we have. I now have two terms. It's this whole thing is one term, and this whole thing is another term. So if you notice, they both have an x plus 5. This is why it's key that they were both the same thing on the inside here. So both our terms have x plus 5s. I'm actually going to factor out an x plus 5 from both the terms. So there's me pulling out the x plus 5, and we're left with an x squared and a minus 3. So that's going to be my other factor, x squared minus 3. And that is an example of factoring by grouping. And if you want to check this, you can multiply this out. You can check this. And you'll get back what I have up there typed up in red. But anyways, that is factoring by grouping. So let's get a little practice with that. Okay, so here's another one to play around with. We're going to factor let's factor x cubed minus x squared minus 9x plus 9. So again, I'm looking at, I notice that there's 4 terms here. I'm going to try grouping. I'm going to factor something from those first 2 terms. Looks like I can pull out an x squared. And what are we left with? Well, it looks like we're left with an x minus 1. So remember, the trick or the catch with this, whenever we factor out from our next 2 terms, we need to be left with what? Well, we need to be left with that x minus 1. So what do I need to do to make that into an x minus 1? Well, it looks like I can factor out a minus 9. Be careful that you bring that sign there. Even if it's a positive 9 that we factored out, you need to have a sign there because you need to show the distinction between these 2 terms that we have here. Okay, so I factored out the minus 9 from the second 2 terms, and now we have an x minus 1 in common between our 2 big mega terms here. So I'm going to factor out an x minus 1, and then we're left with an x squared minus 9. And something should catch your eye with this one, because we've seen this before, right? In fact, we saw this earlier in this exact video. The x squared minus 9 is really a difference of 2 squares, and that should be familiar factoring for us there of x plus 3, x minus 3. Okay, moving on to one last type of factoring. This is factoring polynomials that are in quadratic form. And I'm stressing the idea of form because they don't really look like quadratics until you change the form around a little bit. So a little recall here about what quadratic form looks like. It's y equals, well, we have a coefficient. It's something being squared, right, x squared, plus that same something times b, plus a constant c. Okay, so let's look at an example. So let's say we have a function like, let's see if I can get this to right, x to the 4th, or an expression, x to the 4th minus 3x squared. Actually, I'm going to make this 2x squared. And then minus 3. So at first glance, this might look like something that we're not used to because we have this x to the 4th power here, and we have this x to the 2, and it doesn't really look familiar. Okay, so what I'm going to do is I'm going to rewrite this as something squared minus, in this case, 2 times that same something to the 1st, and then I have the constant of minus 3 on the end. Well, what can we do to rewrite this so that whatever I put in here, when I square it, gives me x to the 4th. Well, as it turns out, it's x squared. When I square it, gives me x to the 4th. And it's that same thing that I can put in over here. So when I go to factor this, I can really think of this as a really different expression, like a squared minus 2 times a minus 3. So what I did essentially was I made a little substitution, if you will. I changed a into x squared. or I changed x squared into a. Because this is now something, this a squared minus 2a minus 3, that's something that's a little more easily factorable for us, right? I can say this is a minus 3 times a plus 1, and then I can just put back the x squared in for a and say that this is x squared minus 3 times x squared plus 1. So that's what I mean by the form is a quadratic. It has a certain ratio, or I can write it as 2 to 1 to 0, right? This is really x to the 0. I can write that in that ratio. So just be on the lookout for coefficients that go like 4, 2, and then, again, 0 over here, because that will be a quadratic form. So let's take a look at an example here, and this will be our last one for this video. So we're going to factor 2x to the 6th plus 4x to the 4th minus 6x squared. So again, what's always the first type of factoring you should try? That's right, it's greatest common factor. So we have a 2 that we can pull out, and we can also pull out an x squared from all the terms, right? So I'm going to pull both of those things out and then see what I'm left with. So if I pull out a 2x squared, well, 2x squared times what is going to give me 2x to the 6th? Well, it's going to be x to the 4th. 2 times 2 is going to give me 4, so this term is going to be 2x squared. And then my last term, 2x squared times what is going to give me negative 6x squared. That looks like a minus 3. And this looks like a very similar problem to what we just did, as it turns out. So let's see what we have here. I'm going to bring down my 2x squared. And I'm actually going to do this in a slightly different way. So if you recognize that we have the form of a quadratic, we know that these terms aren't just going to be x's, they're going to be x squared. And once you do that, then you're just messing around with the coefficients here. So you don't need to do that substitution like I did before. You might find it a little bit cumbersome. But really, you should be able to just write in your x squareds in here, and that might make it a little bit easier for you. Anyways, this factors to, as you should probably recognize from your trinomial factoring, plus 3 and minus 1, or in other words, our solution is going to be 2x squared times x squared plus 3 times x squared minus 1. And if you notice, ooh, I almost missed it myself. That's a difference of 2 squares, isn't it? So I can take this a little bit farther, and we should. So here's our final solution for our factoring. So you folks try this one on your own, and I'm going to put the solution up here right away, actually. You can pause it at this point here. So I see this as a difference of 2 squares. There's 2 terms, 81, 16, those are perfect squares. So I'm immediately going to do this, and I'm going to take the square roots of both of these terms. Well, the square root of 81 is 9. The square root of x to the 4th is x squared, and the square root of 16 is 4. So I'm going to get 9x squared plus 4, 9x squared minus 4. And of course, there's a little catch here. This is, again, the difference of 2 squares. So this is actually happening twice where we're having the difference of 2 squares. We have the 9x squared plus 4. And now we have, this is going to be 3x minus 2 and 3x plus 2. Do you know why this one doesn't get factored anymore? If you're not sure, what kind of factoring would you think it might be? It's not the difference of 2 squares, because this is adding in here, right? So we don't have a sum of 2 squares. We just have the difference of 2 squares, and there's nothing really we can do with that one. So that's nice. We can just leave it the way it is and call it a day. All right, hope you enjoyed this. Hope you learned something about factoring, about grouping, about the sum or difference of 2 cubes, about quadratic form. And I look forward to having you guys practice in class the next time we meet. Have a good day. Take care.